Hello friends, this is Durga again from IT Varsity. As part of CCA Spark and Hadoop developer, at this time I'm talking about calculating aggregate statistics such as average or sum using Spark in Scala as programming language. So far we have seen totals and then we have seen the syntax and semantics of all the aggregate functions supported by Spark, group by key, reduce by key, combine by key, and aggregate by key. And then we have implemented a complex map reducer, a complex Spark application where we have joined the datasets and computed average by key. And in this case, I will show you another example where we actually get max aggregation by key, uh, and also we will try to see how we can do these things using SQL also. That being said, let us define the problem statement. The problem statement is we would like to get the customer ID with max revenue. So I just need customer ID. So in this case, it's actually the problem statement is customer ID with max revenue for each day. So again, we have to join orders and order items. And if you look at the structure of tables of orders and order items, orders have the order customer ID. So I want to get this customer ID with the max revenue for each day. Okay, and again the revenue is in order items table, and customer ID is in orders table, and we have to get the customer ID uh, for each day with the max revenue. That being said, here you have to join these two data sets, orders and order items, and the key is order ID. I have explained these 5 things earlier. So we have passed the order ID from each of the data sets. In orders table it is first column, in order items table it is second column. That's why when we are trying to parse order items, we are trying to get the second field by using subscript 1 after splitting with delimiter comma. So we can directly execute these things in the Spark shell. Paste, everything ran successfully. Now you want to get orders per day per customer. So first let us understand what is there in this. Paste, take of 5 dot for each, println how the data is represented for each record in this join order items dataset. You can see it's a tuple. The first element of tuple is order ID, and the second element of tuple is a tuple again, which have two elements. The first element is the data from order items. It has 6 fields, 1, 2, 3, 4, 5, 6, and then the second element in this tuple is orders data, because we are joining orders with order items, orders onto order items. The first element in the tuple is from order items, and the second element is from orders. Here it is a little bit misleading because comma is delimiter in our data, but this actually represent two different elements in a tuple. That's why the second element is enclosed in the circular brackets. So each record is a tuple. The first element in the tuple is order ID, and the second element itself is a tuple with the first element being from record from order items and second element being record from orders table. Now we have to get customer ID, date. So customer ID and date are in the second element in the nested tuple. This one has the order date. This is the order date, and this is the customer ID. So we need to get these two elements as key, and we need to get the revenue as value for each of the joined record. So we have to apply map function here. So I am trying to get orders per day per customer. I have to apply map function. I will copy from till here, and then I will explain you how I am building the key and how I'm building the tuples. So the output of the map function, let me close the map function first. The output is a tuple, and the tuple will have two elements. The first element will be a tuple, and the second element is just one value, which is nothing but revenue. The first element of the tuple will have the date from here, which can be represented as rect dot underscore 2. So underscore 2 will give us this entire tuple, and then we have to fetch the second element in this tuple, which is again dot underscore 2, and we have to implement split function on that, because data is the string with the comma delimiter, and we have to get date, which is represented by subscript 1, because that date is the second element in the tuple. So now we got the date, and we have to get the customer ID also, so which is represented by rect dot underscore 2 dot underscore 2 dot split comma, and we have to use subscript 2, and we have to use toInt function here to get the to convert the order customer ID, which is integer, to integer from the string. So this will actually return string, the split function, but as it is integer, I am typecasting to integer. And now I have to get the revenue, which is the fifth element, fifth attribute from the order items data set. From this we have to fetch the fifth one, which can be represented as rect dot underscore 2 dot underscore 1. So this is represented by dot underscore 1, from which we have to apply split function and get the fifth function using the subscript 4, and then we have to convert it into float, because it is of type float, and hit enter. Now it has created a tuple of two elements, the first element itself being a tuple, and the second element is just a value, which is revenue, and this one will have date and customer ID. So you can actually validate orders per day per customer dot, what should we do here, take of 5 for each, println, and hit enter. Now you can see that for order date here for this customer, the revenue, the order item subtotal is $299.97, and I have to add all these things so that I get revenue per customer. For that, I will say revenue per customer per day. Let me give it as val equal to, here again we need to determine which aggregate function should we use. In this case it's pretty simple. The input type of the value is float, which is nothing but revenue, and the output value is again float, which is nothing but aggregated revenue for our key. So for that we can just say orders per day per customer, copy, paste, dot, I can just use reduce by key function here, and accumulator comma value has to be added to the accumulator, and hit enter. And now you can actually say copy, paste, dot, take of 5 for each, println, and hit enter. Now you will get the aggregated revenue for each combination of date and customer ID. From this I have to get the maximum customer ID which is generating the maximum revenue on each and every day. Okay, so it's again an aggregate function, we need to determine which aggregate function should we use, and we have to implement the max logic here. So far we have seen only addition. In this case we will be implementing custom logic such as max here. That being said, let me copy this RDD name or variable name. So val max revenue customer equal to, paste it, and I have to apply. Again, we need to determine which function we have to use. In this case also we can use reduce by key, because the input type of the value which will be passed to the aggregate function is float, because it is revenue, and output type is the maximum revenue. Okay, so the input type and output type are same, and we can apply same function in both combiner and reducer. So we can directly implement reduce by key here. Reduce by key, okay, and rec. So this actually this is actually generating the tuple. Okay, before applying the reduce by key function, we need to move out the customer ID to the value, because we want the maximum revenue generating customer per day. So the date should be the key. So before applying the reduce by key function, I am also applying the map function. In this case, the key is the date, which is represented by rec dot underscore 1 dot underscore 1, and the value is a tuple, which is represented by rec dot underscore 1 dot underscore 2, and the second attribute of the value is the revenue, which is represented by rec dot underscore 2. So in the map function, I am generating this as key and moving the second attribute in the key to the value, and now the value will be the customer ID and the revenue for that customer. Okay, and let me validate that before running it. So let me name it as copy, paste, revenue per customer per day map, and then I can actually say revenue per customer per day map dot take of 5 for each println, and hit enter. Now you can see that the first element in each of the tuple is the date, which is key in this case, and the second element is a tuple which has the customer ID and the revenue. Now from this we have to apply the reduce by key function as I have explained earlier, and get the max revenue generating customers for each day. So what is our latest variable? This one. Copy, paste, dot, I have to apply reduce by key function. Rec is the entire thing. In this I have to apply if condition. If rec dot, here I want to the input is also a tuple and the output is also tuple. I am just trying to compare the maximum generating revenue for each day. Let me write the logic, then I will explain. In this case, I want to get the second element, which is the revenue. Sorry, reduce by key take two parameters or tuple of two values, accumulator comma value, and here I have to say if accumulator dot underscore 2, so which is this one. Initially it could be 0, greater than for the first time accumulator dot underscore 1 and accumulator dot underscore 2 both will be zeros. Okay, or it could be null tuple. Okay, and when I compare accumulator dot underscore 2 greater than or equal to value dot underscore 2 So for the first time, accumulate this value will be the greater than accumulator. If accumulator is greater than or equal to value, then you have to return value, which is nothing but tuple. So we are comparing only the second element, but we are returning the tuple here. Else we want to return accumulator. So this is the logic in reduce by key function to get the max revenue generating customer. So here for the first iteration, value will be the first tuple and accumulator could be null. And after applying this function, the accumulator will become value. Here I have to say accumulator value from the first record, and after that it will compare with accumulator will be assigned moving forward with the maximum of the two values. So for the first iteration, in this case, let's say all of them are on the same date. Consider that scenario, and let's say that all of these being compared. As part of the first iteration, we are saying if the second element of the null tuple is greater than or equal to 829.89, then it should be null tuple, otherwise it should be this value. So after the first iteration, accumulator will have this one. In the second iteration, as the accumulator will have this one, we are comparing this value in the accumulator with this one, and then as this one is larger, accumulator will still have this one, and then it will the same tuple will be compared against this tuple. Like that it will move forward, and then it will get the maximum tuple by the end of the complete iteration by key. Internally it uses combiner, but this same logic is additive, so we can actually do the same thing on top of the intermediate results also. Hence we can safely use this reduce by key function to get the desired output in this case. And now you can actually say collect for each println, and here we will say sort by key dot collect dot for each println and hit enter. Now you get the result for July 24th. The highest revenue generating customer is 3,464. And the highest revenue for that day per customer is $1825.75. You can implement the same aggregate functions to get more complex aggregations such as max, not just sum or average. So now we have implemented this we have implemented reduce by key function twice. One is to generate the revenue for each customer for each day, and the second one is to get the maximum revenue generating customer from the data set. And in some cases this logic can be quite complicated, so you should be familiar with about writing regular functions also, not just closures like this. So this is how the regular function look like for this functionality of comparing to generate the max revenue customer for each day. Here you need to match the input parameters. So reduce by key takes two parameters. So you need to have implement the find max function with two parameters, and you need to understand the data type of each of the parameter, and you have to implement the data type here. You can see that before applying the max function, the data type is not this one. This one, the data type is of each tuple is integer and float. So here I am using string because I didn't implement. I haven't done the typecast here, but in this case, if I have to implement, I have to define it as int. So whatever is the data type of the tuple of the value for our reduce by key function, that data type has to be given for both the parameters and also for the return. So this is how you actually return in Scala. And then with equal and by opening curly braces, you can implement the functionality. At the inputs are of type tuples. You have to use underscore notation to compare, and if the second element of the accumulator is greater than the second element of the value, then we are returning the accumulator, else we are returning the value here. So you can actually run this and it will give the exact same results. I have just implemented this greater than or equal to logic in a regular function earlier, or whatever I have demonstrated is from closure or anonymous function in Scala. Now we will see how we can actually do this in Hive context within the Scala. So it's pretty simple. First you have to import org.apache.spark.sql.hive context and hit enter, and then you have to create a variable hive context equal to new hive context sc and hit enter. Now using hive context I can write a query. The query is little bit complicated. So we need to get first to get the revenue, we need to get the distinct number of orders, and then we have to apply that logic. Okay, let me write it for the revenue. So hive context dot sql select o dot order date, because we are trying to get the average revenue by day. So the one of the element should be order date, or one of the columns should be order date from orders table, and then I have to get sum of oi dot order item underscore subtotal divided by count of distinct oi dot order item order id. So I need to get distinct order IDs from the order items itself, and then from orders I have to join these two tables, orders, order items. So to run this, first you need to have Hive tables. If you don't have Hive tables in the default database, it will not run. So first, before writing the query, make sure you log into Hive, because we are using Hive context. Make sure you have these tables, orders and order items, in the whatever database you are trying to use. In this case, I am not prefixing the database names for the tables, so it will get from default database. So now if you say show tables, you can see orders and order items tables here. You can also validate, select star from orders limit 10, select star from order items limit 10. So both the data sets are there in Hive, and now I can join like this. If you are familiar with SQL, most likely the syntax will work. In some cases you need to understand the differences and you have to write accordingly, but simple joins like this, it will work without any issues. On o dot order id equal to oi dot order item order id. Once we join, we have to group by o dot order date, and that's it, and hit and then you can say collect, or you can also say sort by. I will use order by internally only, order by o dot order date. Okay, and then I can use collect for each println and hit enter. By default, it uses 200 partitions. You can reduce the number of partitions using a parameter called set spark SQL partitions equal to 10, like this. Actually, it is Hive context. And then you can run the query. Now it will only use 10 partitions because we don't have very large data set. Using 10 partitions is more than enough. Now you can see that it is giving the revenue, and it has given the same revenue as same average revenue as our earlier program. So like this, instead of writing very complex Scala code to join the dataset and then do the aggregation. If you are familiar with SQL, you can use SQL itself and you can achieve what you want. So I will paste the query here, but earlier to get the same thing, we have written almost 1, 2, 3, 4, 5, 6, 7, 8, 9 lines of code, 10 lines of code. And also you need to be familiar with all these complex aggregate by key, reduce by key functions, and you have to be familiar with how to get the distinct orders from our dataset while generating the revenue and all those things. So if they don't explicitly specify that you have to use a specific aggregate function, you can use the query if you are familiar with the queries, and that will save you a lot of time at the time of the certification. That being said, I hope you are enjoying the content on my channel. If you like this video, please click on the like button. If you want to provide the feedback, please use the comment section of the video. If you have technical questions, please go to Stack Overflow and raise the questions in Stack Overflow. And if you want to discuss further, either on certifications or Apache Spark, please please join my LinkedIn groups, ITversity Apache Spark or ITversity Hadoop Certifications. And finally, if you have not subscribed to my channel yet, please do so. You will get to see a lot more content like this over time. Thank you. Bye.